Hello everyone, and thank you for tuning into the lesson for angles of circles. We're going to be talking about angles formed inside a circle, outside a circle, or different ways that angles can be formed inside and outside. So there's a couple of little basic things to level set. If you look at this angle ABC right here, you get the pen. Okay. Try a different stylus. That stylus didn't work. There we go. All right. If you look at this angle ABC right here, okay, the ends of the angle B and A, they cut off that much of the arc of the circle, of the circumference, okay? That, what I marked in red, is what we would call an intercepted arc. So that angle AOC, right? Usually the interior of an angle we label with a letter O. So let me do that. Come on. There we go. Letter O. All right. So that angle AOC, it's cut off that much of the arc of the circle. That's what we refer to as an intercepted arc. Okay. So, first one is a central angle. So an central angle is an angle whose vertex, point O, is on the center of the circle, hence the name central angle. Okay. And you can measure the distance around the circle in degrees. There are 360 degrees in a full circle, as I'm sure we all know. So the measure of that central angle is equal to the measure of the arc that it cuts off. So if the measure of arc AB is, say, 80 degrees, the measure of that angle will be 80 degrees. Okay? It's a 1-to-1. Very important, because they're not all 1-to-1. So in fact, this is the only 1-to-1. So that's a central angle. Remember, if you need to pause this to catch up with the notes, then pause the screencast, okay? Now let's take a look at this angle. This angle here. The vertex of that angle is on the circumference of the circle. So the vertex of that angle is right here. So the vertex of that angle is on the circumference, not at the center. So the intercepted arc is still this arc AB right here. Okay. However, the relationship between the arc and the angle is different. So an angle whose vertex is on the circumference, like this one, is called an inscribed angle. The measure of an inscribed angle is equal to half of the intercepted arc. Let's make sure you have that down. So if arc AB is 40 degrees, that angle, right here marked angle 1, will only be 20. Vice versa, if I tell you that that angle is 30, then the arc will be 60. Okay? The angle is 1/2 the arc. Or you could say the arc is twice the angle. All right? You have to make sure you get these down. So this one is an angle formed by a tangent right here and a chord. The tangent is the piece outside the circle. The chord is the piece inside a circle. And that is the same as the measure of an inscribed angle. So the measure of an angle formed by a tangent and a chord is equal to half of the intercepted arc. So now the intercepted arc is here. This is the intercepted arc. So whatever that arc measures, the angle formed here will be half of that arc. All right? So because the vertex of the angle is right here on the circumference of the circle. Come on, there we go. All right? The vertex of the angle is on the circumference. It follows the same rule as if it were an inscribed angle. Angle formed by two chords intersecting inside the circle. Okay? Angle 1 and 2, we know that they are congruent because they're vertical angles. They're across from each other. So the way you measure that an angle formed by two chords intersecting inside a circle is equal to half of the sum of the arcs intercepted by its angle and the vertical angle. So, if I look at arc AB and arc CD, if I add those two arcs together and divide by 2, that would be the measure of either angle 1 or angle 2. It doesn't matter, they're the same. So this is the only instance where we're adding the lengths of the arcs. Okay? It's the sum of the arcs, divide by 2. Now I put all of these together because they all follow the same rule. So you have an angle formed by two tangents here, an angle formed by two secants here, or a tangent and a secant here. They all follow the same rule. So the measures of angles formed outside the circle by two tangents, two secants, or a tangent and a secant intersecting is equal to half the difference between the larger arc and the smaller arc. So it's always large arc minus small divide by 2. So here it would be that arc minus that arc and divide by 2. Okay? That's with a tangent and a secant. When you have two secants, it's that arc minus that arc and divide by 2. When you have two tangents, it's that arc minus that one, divide by 2. If you notice in two secants, the sum of the arcs is going to be 360 degrees. You got to remember, angles formed outside the circle this time, not inside. Outside, large arc minus small, divide by 2. All right, let's review this before I end this. Central angle, the vertex of the angle is at the center of the circle. It's a one-to-one relationship between the measure of the intercepted arc and the angle. An inscribed angle has its vertex on the circumference of the circle. An inscribed angle is half of the intercepted arc. An angle formed by a tangent and a chord follows the same rule as an angle which is an inscribed angle. The vertex is on the circumference, point A right here is the vertex, and it's half of the intercepted arc. And the intercepted arc is this arc here, arc AB. All right. Angle formed by two chords inside the circle. That's the only time you add the arcs and divide by 2. Angle is formed inside the circle by two chords. All right. Angles 1 and 2 will be congruent because they're vertical angles. Add the arc AB and arc CD, divide by 2. If we were looking for the others, we would add those arcs and divide by 2. These are all in the same category. The angles are formed outside the circle. Tangent and a secant drawn from the same external point. Two secants drawn from the same external point, or two tangents drawn from the same external point. The rule is the same. Large arc minus small, divide by 2. So I hope everybody's doing okay. We're starting week 2 now of online instruction. If you care to send me, oh, that was the dryer. If you care to send me a little video, you can upload that to Google Classroom if you like. Just let me know how everybody is doing. We're fine here. That's about it. And this lesson was brought to you directly from my dining room table.